Okay, everyone, so starting our unit on sequences and series today. I'm not sure where I am in the picture right now, but I know you can hear me. Just a little bit about how all this is working. You know, I've got days 7 through 10 of AMI posted already in your Google Classroom for this upcoming week. So this first lesson that we're fixing to start here on sequences and series is intended for April 6th. So I'm just trying to stay a little bit of ahead of the plan here and keep us focused on where we're supposed to be looking towards. So this will actually be posted a little bit early, but this is April 6th. So you have this coming up week, which will be starting tomorrow, March 30th, to work on the assignments over or review stuff over rational functions, AMI days 7 through 10. Okay, and then this will be for April 6th, the following, where we're going to get started. Just going to tell you now, these are going to be very short lessons. I know you've got a lot going on. You've got a lot of AMI work. People are sharing devices and sharing computers, and internet might be slowed down. I understand all that. I'm going to try to keep these short. Just introduce a couple of things each day, short, sweet, to the point. You can pause, rewatch, whatever you need to do. Take notes like you would in class, whatever you need to do. But it'll be there for you to review if needed. And then at the end of each short lesson, I'm just going to have a few problems, and those will be your assignment problems. So then you can either open up a Google Doc and share that with me through Google Classroom, where this will be loaded, or you can do it on your own paper, snap a pic of it, and email that to me. Either way, that's fine. But those assignments are going to be short as well. I'm not trying to overload you, but I know that there are things that we still need to cover to make sure you're ready for whatever's next, whether that's taking the ACT or whatever math class you're going to take next school year. We just got to make sure that we're staying on track and being ready to meet those goals. Okay? So this is going to be just like normal. I'm going to walk back to the back and get my tablet that I write on, and I'm going to give you a little bit of notes to start our sequence and series unit, and then I'll end today's lesson with a few problems for an assignment. And that's what we'll do every day until we get to see each other again. And man, I hope that's soon. I miss y'all. Okay, so here we go. Hey, the bells still ring. That's kind of cool. That's good. All right, so just a couple of definitions. Of course, my tablet's been off for a while, so here we go. A couple of definitions to get us started going here. Sequence, so this unit's called sequences and series. So a sequence, what a sequence is to us is just an ordered list of numbers. Okay, nothing earth-shattering there. You already knew that. Just an ordered list of numbers. Now, we're going to see these things written, these sequences and series as we go throughout this unit. We're going to see these written with some funny things, some different letters, and so I'm going to go ahead and introduce those to you now. Anytime we have the capital A, that just refers to a given sequence. So I know these symbols and letters and variables are going to look confusing to you now, but we'll see them throughout this unit, and it'll start to take its place a little bit. Just anytime we see the capital letter A, that refers to a given sequence. A lowercase n refers to the position, whoops, only one S, I still can't spell, P-O-S-I-T, refers to the position of a term within a sequence. T-E-R, look at me, I think I've been out of school for a while. Position of a term within a sequence. Okay? Then we've got a lowercase a with a subscript n. That refers to the term that's located in the nth position. And we're going to see examples of all this, just stay with me. And then a capital S with a subscript n refers to the sum of a given sequence. Given, what's a G? Given sequence. Okay? Now, out of these sequences, we started here with sequence, there are two types of a sequence that we're going to discuss. So the first type is a finite sequence. And then you already can figure out what the second type is. It would be an infinite sequence. And none of us are dummies, so we know what is implied with both of these there. A finite sequence would have to come to an end. So a book definition would say this is an ordered list of numbers, using your sequence definition. This is an ordered list of numbers that has a last term. Okay, so it comes to an end. It has a last term. And we know what infinite means down here, so using our definition of sequence, we could say it's an ordered list of numbers that continues indefinitely. That'd be one way to say it. Continues indefinitely. D-E-F-I-N-I-T. Or if we played off of our previous definition for finite, finite has a last term, so infinite does not have a last term. We could add that. No last term. Okay? Hold on just a second. My niece is calling me. Let me see what she needs. Hello? I'm teaching some math lessons right now. I don't know. I probably just don't need to do it today. Bye. Okay, she was wanting me to go climb Pinnacle, so I had to back out of that. Alright, so let me go through and give you some examples now of both finite sequences and infinite sequences, so we can talk about what some of those letters and just dive into this and see what some of this stuff means. So here I'm going to use A because on a previous page we said A refers to a sequence. So I've got a sequence that has 1, 3, 5, and 7 in it. So if that's all I give you is that sequence, that's an ordered set of numbers, and I ask you, is that a finite sequence or an infinite sequence? Okay? Is this a finite sequence or an infinite sequence? Your answer would be finite, because you can definitely tell me the last term here is 7. So this will be a finite example, an example of a finite sequence because its last term is 7. Okay? Excuse me. Then from there, we can say that the first term, using our new symbols, the first term is 1. See how this is working here? My second term is 3. See, that's the first term, that's the second term. So my third term is 5. And my fourth term is 7. Okay, so nothing earth-shattering there, just using the new lingo that we're dealing with. Now I could change that. All of that is true. So let me get a new color here and give us another one. I'm going to say this sequence, it's going to start off looking the same. This sequence is 1, 3, 5, 7, ... So compare the blue sequence to the black sequence, and what's changed is I've added this ... So what does that mean? What's the last term? Well, now we don't know anymore. We don't know the last term because that ... means the pattern keeps repeating. So since we don't know the last term, this would be an infinite sequence. Okay? But we could still list the terms that we have. You know, these are still the same. Our first term is 1. Our second term is 3. Our third term is 5. And our fourth term is 7. But what could happen here, if I ask you to, is we could continue this pattern, and we could say our fifth term would be 9. Our sixth term would be 11. We could keep that one going because the ... means that one's going to go forever. So here we only have 4 terms, bam, end of the story. Here it keeps going forever, ... Okay? Everybody seeing that there? Okay? So, n, then, what do you think the n would be? Hold on a second, I'm trying to, here we go. What do you think the n would be on our first example up here? And I kind of just told it to you. What do you think the n would be here? How many n stood for? Go back and look at the previous page, look at your notes. N stood for the number of terms. So how many terms are here? 1, 2, 3, 4. So that one would have an n of 4. What would the n be in this one? It wouldn't have 1, because the number of terms is infinite, so it's going to keep going forever. Okay? Alright, so I told you short and sweet. That's it. That's all we're going to cover in this lesson today. So now I've got just 6 problems that I'm going to assign to you. So this is your April 6th assignment. I need you to label each sequence as infinite or finite. And if it's finite, identify your n. Okay? So for number 1, you've got 2, 4, 6, 8, 10, 12. For number 2, 17, 34, 51, 68. For number 3, 21, 18, 15, 12, 9. Number 4, count the 5s, 5, 10, 15, 20, 25, 30, 35. Okay, then we'll jump over here for number 5. 1, 2, 3, 4, 5. And then my last one, 100, 75, 50, 25, 0, negative 25, negative 50. And let me fix this number 4. That's pretty messy as I'm glancing there. Let me just clean that up for you. For number 4, we've got, counting by 5s, 25, 30, 35. We'll go ahead and extend it out to 55. I like 55, double 5. Okay, so you have 6 problems. This will be AMI Day 12.